we're back. This is Techmath1. We're looking at the chapter 3-4 review 2. This is review 2, part 2, and we're picking up on number 18. All right, so how many liters of a 20% solution must be mixed with 12 liters of a 50% solution to get a 30% solution? Okay, so basically we've got 12 liters of 50%. We don't care how much we end up with at the end, like the amount, but we want it to be a 30% solution. And so what we're going to do is we're going to dilute it with a 20% solution. So these are mixture problems, and mixture problems always kind of set up in the same way. So 20%, so 0.20 of X. Now, we don't know how much of the 20% we're going to add, plus there's a 50% solution that we have 12 liters of. So we've got that number and that number. So we know how much alcohol is there, is like 6% of pure alcohol there, or whatever this is, whatever this chemical is. And then 30%, and now here comes the tricky part. So look, we don't know how much we're going to end up with. They didn't say we want 80 milliliters of it. So what we're going to end up with here is however much extra we add here to the 12 that's already there. So this is going to be X plus 12. It's always this plus this is the total amount. It's a mixture problem. And so you can think of it as a base, like the base is X plus 12 equals X plus 12. And then you put in the percents, 0.2 of the unknown, 0.5 of the 12, and we want a 0.3 mixture, all right? After you get it set up, it's just going right back to what we did on the first couple of pages of this. We do the distributive property, 0.2x plus 6, 0.5 times 12 is 6, 0.3x plus 30% of 12 is actually 3.6. You take 0.3 times 12 in your calculator, it's 3.6. And now I just left it at decimals. Like sometimes people will multiply everything by 10 so they can work with whole numbers instead. I don't do that. It's not that tough to work with decimals. For me, if it is for you, have at it, and you can multiply everything by 10. So we did the distributive property. We moved the variables over to the right side, got 0.1x. We moved the 3.6 over to the left side. We got 2.4, and we divided by 0.1. That's 24. And that's going to be liters of the 20% solution. Let's see if that makes sense really quick. I think it does. 30 is right in between 20 to 30, and which is 30 closer to? Is 30 closer to 20 or is 30 closer to 50? So let's think about it. 20 to 30 is 10, 30 to 50 is 20, right? So we would need more of this amount to get it to a 30% solution. In fact, double the amount of what we had of the 12. And so it makes sense that we had to add more 20% stuff to bring down the 50 to a 30. You know what I mean? Had it been exactly dead center, if it would have been, 35, then it would have been 12 and 12. Then it would have been exactly even. But because 30 is closer to 20, it makes sense we have more of the 20% solution than we have of the 50% solution. Hopefully that makes sense to you. All right, let's look at number 19. If 1 pound is equal to 453.6 grams, how many pounds are in 1,000 grams? And again, I showed you in the notes that there are actually 2 different ways to do this problem. I'm going to do it with a proportion. 1 pound is equivalent to 453.6 grams. And now you just have to, when you set up a proportion like this, pounds across from pounds, grams kilograms across from grams, and then they gave us 1,000 grams. And that means X pounds. And so we cross multiply and solve, boink, boink. 453.6x is equal to 1,000 times 1, which is 1,000. And then we divide both sides by 453.6. And so x is equal to 2.204585538, except they want it to round it to 10th place. So, wait, what is that, a 0? That's a 0. So we look at that, and that is not enough to bump it up, so just 2.2. And that was pounds. All right. Lovely, doubly. Let's look at the last 3 problems on the review. So D is equal to 170 kilometers when T is equal to 2 hours. Find D when T is 5 hours. All right. Okay. Distance is equal to rate times time. So I think on when I worked out the packet, I set that up, instead of as a varies directly problem, I just set it up as a proportion problem. Let's see if we get the same answer. I think we're going to get the same answer, but let's double check that one. So here comes the double check on that. D is equal to 170, so that's the distance. T is equal to 2 hours. That's the time. So we said distance equals rate times time. And so it's like a varies directly problem. So 170 is equal to R, which we don't know, that's going to be our constant, times 2. So we're going to say 2R. So we divide by 2. And what is that? That's 85, I think. Right? Half of 170 is 85. So our rate is 85 kilometers per hour. But now we set up another one, distance equals rate times time, but this time we say distance equals 85 times time. And then they said for 5 hours, so distance is equal to 85 times 5, and 85 times 5 is 425. Yeah, so I did it as a proportion where I said if you're traveling 2 hours and 170 kilometers and then set it equal to 5 hours and X kilometers. And so you didn't necessarily, for this problem, have to use varies directly. I don't think it ever said varies directly. I just looked at it as a proportion problem. So a proportion would also work, how I set it up on the thing for that one. But now for 21, that's different because it says the pressure of a gas varies as the volume of V, varies inversely as the volume V. If P is equal to 4 kilometers or kilograms per centimeter squared, when V is equal to 15 liters, find P when V is equal to 10. All right, so this one is a varies inversely problem. So I didn't write that down. A gas varies inversely, but you should have the actual thing written out anyway for you. So varies inversely means this. Remember y equals k divided by x, except this time it's going to be P varies inversely as the volume V. So instead of y equals k over x, we're going to put p equals k over v. Now we're going to give the stuff they gave us. So they gave us p was 4 when v was 15. And then we cross multiply and solve. So we get k is equal to 4 times 15 is 60. So that's my k. Now we redo this equation. But instead of k over v, we put 60 over v. All right. So there's our brand new equation. P is equal to 60 over v. And then they say, okay, what about when v is 10? Well, then p is 6. And that would be the kilograms per centimeter squared. This one, the only problems on this test that I'm worried about a label is when you are working with the percents. If it's a percent, I want you to tack a percent sign on there, all right? Otherwise, yep, no worries. All right, so let's do the last problem on this review. So 22 is the power P an electric circuit varies jointly its resistance R and varies jointly with its resistance R and the square of its current I. So that means it's this y equals kx squared z, but we're going to put in P power. An electric varies jointly, so K comes first, and then R resistance and the square of I. So R I squared. Okay, well here I'll put ZX squared then. Really doesn't matter which order you put them in. If you want to go KI squared R, that's fine. All right, so now they tell us P is 180. They tell us I is 3 and R is 20. And now, please excuse my dear Aunt Sally, we do exponents before we multiply. So this becomes a 9 times 20 times K is equal to 180. That means 180K is equal to 180. That means our K is kind of useless, right? Just 1. So if K is 1, I write out P equals KRI squared, but that's going to be a 1 times RI squared. Okay, and so now we put in, it says find power if I is 5 and R is 10. So P is equal to, I'll still put the 1 there, but you don't really need it because 1 times anything is 1. So R is 10, I is 5. But again, be careful on this. So many people, last time I taught this last year in fall, just wrote 5 times 10 and put down 50. You know, most people got it right, but the people that got it wrong, that was the mistake they made. They forgot about the squared. They had it in here, but they forgot about it there. So don't forget about it there. So 5 squared is 25 times 10 times 1, I guess. And then that's 250. So power is 250, and that's in watts. Again, those units I don't really care about. Just remember to get the units marked correctly when you're doing just percents. I need that percent sign on there. All right, excellent. Good luck on that test.